Good evening, McKeel. I'll be leading tonight's discussion. Cassie has connected our audio. I want to connect too. Okay, that you have your audio on. If you have your audio on and can hear me, can you kind of type a Y into the chat window just so I can make sure? Okay, Sarah can hear me. Has her audio on, and Brandy has her audio on. Wait, Brian and Sarah. Let's see, I'm hearing sound from somebody. Brandy, can you turn your speaker off?
Oh, sorry, yeah, I'll do that right now.
That's okay. Sarah, I see you've turned your speakers on. If you can hear me, can you just type a little Y in your chat window? And brought your speakers on. Just in the chat window to let me know that you can hear. Okay, so Brian, now I'm waiting on Raymond. He needs to turn his on. Oh, can you hear me? You could type a little Y in the chat window. That'll let me know that you can hear what's going on. Quite a few people in here tonight. The purpose of tonight's math chat is to go over some of the practice problems we have on the practice exams. I'm assuming that you have each received these exams either in class or by an email that I think Joe Houston sent. So, I've got them here tonight. And what I want to do is go over any problems in particular that you guys want to go over. So if there's something that you want to work on, chat to me in the window, in the chat window, and I will go specifically over the problems. We touch on what's bothering everyone. Okay. And could you turn your speaker off? Problems in particular they want to work on. If not, we'll just start working on Form A, number 1. Okay, I'm not seeing any. So, Cassie, is it number 6 on this form, Form PA? Okay, so let's scoot down here to number 6. Let's see if I can do that. Okay, can everybody see the form on your screens? Now, in the past, you guys have had to adjust your screen sometimes so you can see the full problem being worked out. If you see the form on your screen, let me know and we'll try to figure it out. Lassie has requested number 6. So let's work it out. It is let me get mine going. Absolute value inequality. So anytime you have an absolute value, these bars here, we know we're going to have to solve the problem in 2 ways. Okay. First thing you have to do is isolate the absolute value. Get it by itself on one side of the equation. We've already done that. There's nothing being added or subtracted, multiplied or divided by this absolute value. It's already isolated. So we're ready to solve it in 2 ways. First way is to be just drop the absolute value bars and leave it as is. That way. The second way is to drop the absolute value bars, flip the inequality, and make what's on the other side negative. So, okay, it's just a matter of solving these problems. So I'm going to bring the 2 over to the other side. We'll have x are equal to 5. And then we divide by 5 here. So this cancels. We'll have x is less than or equal to 1. And here we're gonna solve and play the same way. And x is greater than or equal to -9. So when we divide 5 down here, we'll have x is greater than or equal to -9/5. Okay, we're asked to express this in interval notation. What I like to do is graph this on a number line. So I have -9/5 down here, and we're here. Now, graph x is less than or equal to 1. That's then we've got an equal sign, so we're going to use a bracket. That's go this way. And greater than or equal to -9/5 would go this way. With the want is the overlap. So we want from here to here. So like this. The bracket 9/5 to the 1 with the bracket. So I've got answer A. That's everybody. And that one, and what I've done on that one. Okay, and have any special requests from Form B? Work on either of those tonight. Input. Let's go back up to the top of the page here. Let's see some order of operations. From page. Let's do it that way. Okay, choose number 3 here. Looks like we lost our fraction bars. Okay, got an equation here with a bunch of fractions in there. I don't particularly like working in fractions. So my goal is to get rid of the fractions. The way to get rid of the fractions in equation, now we have the equal sign here. This is an equation. We've got the equal sign, so we're good to go. We need to find the LCD of the entire equation. If you look at your denominators, we've got 5 and a 6. We're looking for the lowest number that both 5 and 6 divide into. The only one I can think of is going to be 5 times 6, which is 30. Okay, so our LCD, we're going to multiply 30. I'm going to put 30 up here, 30 over here. Okay, 30 multiplied by each of these terms, we get some canceling. Okay, 5 will go into itself one time, goes into 36 times. Okay, so move over here. What we left of this first term is going to be 6 times 4r minus 3. Now, the next term, 6 goes into itself one time. 6 into 35. So, remember, minus in here, so we have to bring that along too. Minus 5 times r minus equals. Okay, now cancel on this last one. 5 goes into itself one time, 5 to 36 times. We're left with 6 times 6. We'll put that here like so. Okay, so we've gotten rid of all of the fractions. My major goal. I hate fractions, so I like to get rid of them. Now, we are in an instance where we have to distribute. So we'll distribute this 6 through the parentheses here and here. 6 times 4r is going to be 24r. 3 will be negative 18. And distribute the negative 5 through the next parentheses. Negative 5 times 7r will be negative r. Negative 1 is positive 5. And this is the 6. We've done all of the distribution. We can combine our like terms. Let me change color here. So our like terms. We have r here and an r here. When we combine them, 24 minus 35 is negative 11r. And when we combine the terms, our negative 18 and our positive 5, then we get negative 13. Okay, and then to blue. Okay. Okay, we want to have our variable on one side. Our variable is the r. We want to get everything else on the other side. Going to add 13 to sides of the equation. Plus negative 11r on this side equals, now 6 plus 13, that's good. Oops. Negative. Oh, that's not a negative, that's an equal. Sorry. I saw equal sign, I thought it was a negative. 36 plus 13, 49. Okay, we're going to solve for r. Last thing to do. Negative 11 divide by negative 11. Answer, negative 49 elevenths. Answer A over here. Okay. Any questions on that one? Kind of lengthy because getting rid of the fractions take a while, and then solving the rest of the equation can take some time too. Okay. Oh, I see you guys are chatting with me. I didn't see. Oh, perfect. Cassie has some suggestions, and Grace has some suggestions. Perfect. Okay, let me write these down before I lose them. Perfect, guys. I didn't see your chat. She has number 18, 24, and 28. And Andres wants number 4. And Sarah would like to do number 9. Okay, great. So I'm going to go ahead and work on those ones that you guys have asked about. Let me go to number 18 first. Let's find what page that's on. Okay. Okay, rationalizing a denominator. Okay, the first thing you want to do when you rationalize a denominator, you notice here on what we've here. Everything is under one root. This is a third root. That little index 3 means third root. I want to split it up so that we have two roots. I'm going to do the third root of 3x, the root of y squared. When it says rationalize the denominator, we do that because we are not allowed to have radicals in our denominator. So the whole goal is to get rid of the radical in your denominator. We need to figure out what do we need to multiply this denominator by to get rid of it completely. Okay, it's always going to be the same index in your root that you're starting with. You're starting with a root 3, you're going to multiply by a root 3. You notice here we have 1, 2 in here. We've got 2. We're groups of 3. That's what this index means. So have 1, 2. We're looking for 3 2's. We need 2 more. So 2 more 2's would be 2 times 2. That's going to be a 4. The y, we have 2 y's. We're looking for 3. We do more. So place 1 underneath there. Now, whatever we do to the bottom, we have to do to the top. So again, we're going to multiply by the cube root of y. We're just going to multiply it across. So the cube root of 3x times the cube root of 4y is, of course, going to be a cube root. Apply the 3 times the 4 to 12. X is not, there's only one x, not multiplied by any other x's, so it's just going to be x. Same with the y. Okay, now underneath here, if we were to multiply it all together, which I didn't do in this one, some of you may be skipping this step at this point. So 2 times 4 is going to be 8. Y squared is going to be y cubed. Now, if we simplify this denominator, so it breaks down to 4 into 2 and 2. So it's 1, 2, 3 2's. We are looking for 3. So we can take that 2 out. Same with the y's. We have 3 y's. We're looking for sets of 3. So we're taking out 1 set of 3 y's. Exponent on this y is actually a 1. I'll put it there, but anytime your exponent's a 1, you don't need to show it. Okay, there's nothing we can do on this numerator. There's sets of 3, anything that we can take out, so it's going to stay the same. Okay, Cassie did not understand how I got the 4. Okay, coming back to this first step. We had a 2 underneath the radical. Well, we're looking for sets of 3, so we need 2 more 2's. We'll put 2 more 2's under the radical. The reason I showed 4 is that I just multiplied the 2 times the 2 to 4. Does that make sense? Great. Okay, so it looks like our answer is cube root of 12xy over 2y. Like it's option C. Okay, that's how you rationalize that denominator. Any questions? If not, head to the next request. Okay, number 24. So, and that one. Okay. The graph. Using the graph they give us here, we find the domain of the function using graph. Okay, so I'm going to remind you guys, domain is all values. Function. The range is going to be all y values, include function. So if we're looking for the domain, we are interested in all of the x values on this function. Now remember, the x travels from left to right. So in this direction, we've got the x's. arrow right here means this function is going to go down and to the left forever. So it's going to keep going and going and going. This one means it's going to go down and to the right forever. So looking at the x values, if this keeps going to the left forever, this keeps going to the right forever, we have all real values included in our domain. Every x on the axis is possible. So the answer is going to look something like this. Negative to positive infinity. We include every single x value. Now the range, the next one is the range. That's all the y values. Y values, we're going to start from the bottom and go to the top. These are our y values. Again, these arrows, like I said before, they go down forever. They're going to keep going down. So our lowest y value then is negative infinity. It's never going to stop. It's going to keep going. We can't really name that, so we're going to say negative infinity. Goes forever. But look at this. This is a parabola, and our highest y value is here. Okay? The peak of that parabola hits the number 4. Okay? So we're going to have a 4 here. Think about, are we going to use a parenthesis or a bracket? Means that the number is not included. A bracket means it is included. Well, clearly we can see that at x equals 1, y equals 4. So that 4 is included, and use a bracket. So A looks like the best option on number 25. Define domain and range using a graph. Any questions on that number? If there's, move on. I'm here. Good? Okay. All right. We've got a couple people who don't have their speakers on, so hang on a second while I remind them. So it looks like number 28 was the next one that was requested. Okay, 28 is down here. We want to find all real solutions in exact form. The equation P equals the square root of 3P plus 10. Okay, so we have a square root. Anytime you want to have a square root, you want to isolate it to one side. You want to, if there's something added or subtracted or multiplied or divided, you want to get rid of it. 1 is already isolated. We don't have anything else going on this side of the equation. So we're going to move forward. How to get that, this P plus 10 out of the radical, we are going to have to square it. Okay, squaring it. Whatever side of the equation you have to do to another side. Okay? So we're going to square that side too. Now when we do that, I'm going to move over here. So that gives us P squared on the left. On the right, whenever you square a square root, that means whatever's inside the radical is going to come out. In other words, this here cancels the square root there. Okay, so we're just left with 3P plus 10. Now we have a squared variable. Anytime you have a squared variable, we can call this a quadratic equation. And in order to solve a quadratic equation, all the terms have to be moved to one side. I like my squared variable to be positive. It's already positive, so I'm going to keep it where it's at. Okay, now, so subtract the 3P and the 10. Okay, squared minus 3P minus 10 equals 0. Now everything to one side of the radical, we go ahead and solve. The way we're going to factor. so I know I'm going to have P here and P here. Now I'm looking for two numbers that multiply to be negative 10, but that add to be positive 3. So if we multiply to be negative 10, add to be negative 3, we're going to look at our factors here. So 10, I know I've got 10 and 1. There's a combination that's going to give me 3 out of 10 and 1. So let's move on. I've got 5 and 2. Can we get a negative 3 using a 5 and 2? Sure can. We can use negative 5 and a positive 2. That will add to negative 3 and multiply to be negative 10. So going back here, we're going to put that in. Negative 5 and 2. I'll change color. So coming all here, here's to set each factor and solve. So minus 5 equals 0, plus 2 equals 0. And solve, we're going to get P equals positive 5, and P equals negative 2. Okay, so the last thing that you have to do in an equation that involves a radical, like ours did, is going to have to plug your solution back into the original equation to see if it works. Sometimes it will not work and you'll have to throw it out. Here, we're going to check. Okay. We're going to see if 5 works. We're going to use our original equation, P equals square root of 3P 10. Okay, in 5, P is 5. The square root of 3 times 5 plus 10. And again, if you can't see what I'm writing, you might need to mess with the arrows on your screen. You might have to stretch your screen to see everything that I'm writing. So that gives us 5 equals the square root of, now 3 times 5 is 15, plus 10 is 25. Okay, 5 equals the square root of 5. That works. Okay, so P equals 5 is a solution. Now we're going to check 2. Let me switch colors again. We're going to check 2. No, negative 2. Okay. So that'll look like this. We'll plug in negative 2 for P. We get negative 2 equals square root of P times negative 2. Okay, gives me negative 2 equals, okay, 3 times negative 2 is negative 6. If we add 10, we're going to get positive 4. Now, this is a true statement. Negative 2 equals the square root of 4. Right, because the square root of 4 is just going to be 2. So we can't have a negative as the answer of our square root. So we have to throw out our P equals negative 2 solution. So if you had this kind of problem in a test, your answer is going to be P equals 5. Okay, questions on that problem? The last is very important. If you had written P equals 5 and P equals negative 2, you maybe would have gotten half credit, but you definitely wouldn't have gotten the problem exactly right. Okay, 28. Okay, for number 4. So back to the first page. 4. Okay. Simplifying. Okay. Here, so let me put there it is in front of that 4. They're negative in front of that 1, and negative in front of the 2. Lots of negatives. The other ones came out okay. Okay, so let's work on this one. It's a different color. Okay, I have negative exponents. I have negative exponents first. I'm going to apply this exponent out here, this 3. So, a couple of steps together. Let's do that. So negative exponents are here, 2 to the negative 4th. In order to make an exponent positive, I'm going to move it. If it's in the numerator, I'm going to move it down to the denominator. If it's in the denominator, I'm going to move it up to the numerator. To the negative 4th, and take care of the negative by moving the whole 2 to the 4th down to the denominator. Now it's positive. Now, the m to the negative 1, again, I don't want a negative, so I'm going to move it down here to the denominator. It becomes positive. Okay, now I'm going to work on these guys down here in the denominator. Okay, to apply this negative 1 through the parentheses. I have some 1 here. Okay, so I'm to multiply. So on my m, I'm going to have m, and negative 2 times negative 1 would be positive 2. So that's positive 2. And the k does not have an exponent on it, so we assume it's a 1. So 1 times negative 1 is be negative 1. Okay, I'm going to put that here for now. We'll move it in the next step. I'm going to apply the exponent of 3 up top. So 3 here, raised to the 3rd power is 27. 3 raised to the 3rd power means 3 times 3 times 3, which is 27. And says, it shows both negative. Yes. I think both exponents were negative, so I think we're good there. Okay, so let's continue. On the k of negative 2, we're going to raise it to the 3rd power, which is going to multiply the exponents. Negative 2 times 3 will be a 6. Okay. We still have some things we need to move. Okay. Out of room here. I'm going to come down here. Okay. I'm going to stay up top. To the 4th, I'm going to evaluate 2 times 2 times 2 times 2 is going to be 16. 16 is going to go down there. The k to the negative 6, we're going to move down to be this. And we had m squared on the bottom. No, we had m was m to the 1st, and it's multiplied times m to the 2nd. So here, combining these two, when we multiply variables with different exponents, we're going to add the exponents. Okay, that's going to be an m to the 3rd. And then this k to the negative 1, we can move up. That's going to be k to the positive 1. Okay? Now, one more thing we can combine here. We have 1k up numerator and 6 of them down in the denominator. Get rid of this one and subtract 1 from this exponent. So, okay, we're left with 27 over 16, okay, 5th, m to the 3rd. Okay, looks like option. Okay, isn't the negative 2 a positive 2 now because it was multiplied times negative 1? Yes. So right here, Cassie, is where we turned it into a positive 2. But move to this step down here, we have m to the 1st power times to the 2nd power, which when we add the exponent is going to be m to the 3rd power. It's confusing, and if you have to do it in more steps, that's not a big deal. You take as much time as you need to on these and as many steps as you need to in order to get the right answer. On that one, That one confusing. So far, good? All right, let's see. I had a request for number 9. Find number 9. Let's go to the next page. So number 9, I believe, is missing a big fraction bar right here. So number 9. I'm actually going to open up another whiteboard because I think we're going to need more space on this. Write this one down. It 1 over x squared minus over y squared 1x 1 over y. Okay, a couple different methods that we can use to solve these very complex fractions. What I'm seeing in the Academic Success Center is most people like method 2, which is finding the LCD of the entire equation, which means look at every single term, find D. So we have an x, circle all of our, an x squared, a y squared, an x, and a y. Okay, so our LCD then is to be x squared, y squared. Include every single one of these factors. Once we've found the LCD, we're going to multiply each term by the LCD. I can't see my writing. You may have to stretch your screen a bit. If you do that, you'll figure it out. So we're multiplying each term by x squared, y squared, squared, y squared. Okay, change colors again. So when we do this, we want to do some cancellation. Here, the x squared can cancel. And we're left with on that first term is y squared. Okay, for our negative. On the second term, the y squareds cancel, and we're left with x squared. Next one, this x cancels one of these, so left with x, y squared. Bring down. This y cancels one of those, so we're left with x squared. We're down to one fraction, which is a good thing, but we need to simplify it to see if there's anything else that we can cancel. So simplifying means finding greatest common denominators, factoring, anything that will make this fraction simpler. So y squared minus x squared is the difference of squares. It factors like this, y minus x, x. Now here, we can't quite factor it like the difference of squares, but we can take out a GCF. Each term has an x in it, each term has a y in it. So let's factor that out. Once we factor out an x, y, we're going to have y left over, and then minus x. Okay? So now we can cancel where we can. With minus x, we'll cancel with y minus x. So our final solution then will be y plus x over xy. Questions on that one? I got a method if you wish. This is quicker. Okay. So good on that one. So that was number 9. Back here. And we go with y plus x over xy. So it looks like this right here. Okay, so I've had a couple more requests on, okay, looks like Form B we want to move to. Let me find that. Okay, Form B, I see number 34 and 11 as a request. So let me move Form B. Okay, Form B. Number 4. 4 is a graphing inequality. Hold on, pen back up. Okay, in order to graph a line, we want it in this form, the y equals mx plus b form. Okay, so when we do that, the whole gist of that is that you want to isolate the y to one side of the equation. Okay, starting with 4x minus y is greater than 4, I want to move that 4x to the side, so we're going to subtract it. Down here, we're left with negative y greater than negative 4x plus 4. Okay, we almost isolated the y. We have this negative that we need to get rid of. The way to get rid of that negative, it's a negative 1 basically that's multiplied by y. So we want to divide by negative 1. And when we do to one term, we have to do to all the terms. Now, the other key on this is anytime you divide by a negative or multiply by a negative, we have to switch the inequality. So this becomes y, negative 1 divided by negative 1 will cancel. We're going to flip our inequality because we have by a negative number. Divided by negative 1 becomes a positive 4x. And positive 4 divided by negative 1 is a negative 4. Okay, now we're in this y equals mx plus b format. We're going to ignore the inequality symbol for a second. And we're going to graph the line y equals 4x minus 4. Okay. But because our inequality sign does not contain an equals, we're going to make it a dashed line. Our y-intercept here is negative 4, so we're going to start by plotting point. We're going to use our slope of 4, which means we're going to go up 4, 1, 2, 3, 4, and over 1. So that'll be the next point. Okay, sign is going to be dashed through points. Not to be exact, but it's got to, you got the right y-intercept, and your second point's got to be right on. So now we're going to look at this inequality. Our y's are less than that line. So we pick any point on that line. Say we pick our y-intercept. We want less than. So we're going to go down. We're going to shade down. Okay, so that means this whole side here is going to be shaded. We just fill it all in. So put lines. People draw the whole thing in. What you want to do to make your professor understand that you know that you want to include all the values that are on the shaded sign. So that's how number 34 would go. Okay, still confused on why you shaded that side. Okay, so we're going to go back to, okay, you understand how we got this equation here. Y is less than, okay, as to how that first out. Okay, let me do graphing again. Okay, get rid of all this. To graph a line, I'm going to use, so in this y equals mx plus b format, the m is slope, and the b is the y-intercept. So when we graph, we're going to start with the y-intercept, the b. In this case, it was negative 4. So we're going to go on the y-axis to negative 4. That point is definitely on our graph. It's our y-intercept. Then we use our slope, which is 4. So 4 in a fraction form is the same as 4 over 1. And our slope is rise over run. So up 4, let's count 1, 2, 3, 4. So that would be up here. And over 1. Now over is always to the right. Okay, to the right 1. Our line with this at, we don't here, it's less than. We would actually have to dash it. Let me erase around here. And I'm going to close again just to avoid confusion. So draw a line through those 2 points, but we're dash it. It's less than. It's not less than or equal to. It had been less than or equal to and included this equals, their line would be solid. But does not include the equal sign, we're going to dash it. Now look at the equation. Y is less than 4x. And y is less than x. Okay, the line here that we've drawn is the 4x minus 4. We want our y values to be less than. So if you pick any point on this line, say you pick to this point right here, we want our y's to be less than that, okay? So that's going to be down. So anything less than this line is going to be included in this less than. That's why we shade this. It's been greater than, if our y's had been greater than, then we would have shaded the other side. Because picked any point on that line and gone up. Okay, clears things up. It's not a question. Okay. Let's see, I got it. Good. I'm going to go on to number 11, and I also see a request for number 2 on that form. Okay, let's move on to number 11. Again, you can ask me questions on any of them. I see a number 29 too. Let me write that down. Okay, to 11. We're trying to get as many done as we can tonight. We'll be day 2 if we don't get to everything. Okay, come on. Number 11. I think I'm going to open up another page on this one too, because it's going to involve a lot of work. Okay, then says 1 over p minus 1 over p over p 2 over p plus 1. Okay. Using the same method that we used on the last one, we'll figure out what our LCD is. Okay? So LCD includes all of the factors of all of your denominators. So it looks like we've got a p in there. That'll cover this one and this one. And a p minus 1 and p plus 1. So a super huge LCD. Unfortunately, sometimes that's what you've got. I'm going to try and fit it in here. We're going to multiply each term by p times p minus 1 times p plus 1. Plus 1. P times p minus 1 plus 1. P times p minus 1. P minus 1, P plus 1. Okay. And push here so we don't get too confused. Okay. Looking at the first term, we can cancel the P minus 1s, and we're left with P times P plus 1 and 1, which I don't need to show. I'm going to down the minus. Okay, on this one, the cancel. But nothing else remains. So we've got P minus 1, P plus 1. That's tedious, I can see. Okay, the P cancel on the third term. We're left with P minus 1, p plus 1. Okay, the p plus 1's cancel. Ooh. Your screen. I need you to not share your screen. Okay, you can figure out how you're sharing your screen. Somehow you've taken over mine and I can't show mine anymore. So Rena, please unshare your screen. Okay, I'm going to see you too. Gosh, I wish I could figure out how to take controls away. Got control back. I just need to find where we were working. I was working on a whiteboard. There we go. All right. So on this fourth term, our p plus 1's cancel. Okay, so we can get rid of that. We have the 2, the p, and the p minus 1. So down here. Now, above here, I'm going to work on this one. So p minus 1 times p plus 1, we can basically FOIL that. So it's going to be, okay, let me work here. So this distributed here, p squared plus p minus, I'm going to put parentheses because this is going to be a big FOIL. So we have p squared p minus p. So those two middle terms are going to cancel each other, and then you'll have minus 1. Okay, down here, we're going to fold these together. It's going to be p squared minus 1. And then this is going to turn into negative 2p squared. Okay, 2 from the left denominator. Oh, yeah, you know what? I missed that, didn't I? Excellent. Thank you, Cassie. I appreciate that. So there's a 2 outside of this one that I totally forgot. Not go away, but I didn't see it. So thank you, Cassie. I'm definitely going to put that back in. The first one, again, was minus 2p squared, and then negative 2p times negative 1 is going to be plus 2p. Okay. All right. So on the other one, you put x squared and y squared only. Why did you not include the x and y like you included p here? Okay, so I think you're referring to the last one we did. The last one had x squares, y squares, x and y. The x squared contains the x, and the y squared contains the y. On this one, the p minus 1 does not contain the p. That's completely different. Something's being done to the p in p minus 1 and in p plus 1. So this p is different. That's why we had to include it also. Okay? So I hope you guys can follow along here. Let me change colors again. Now I'm going to simplify what we had up here on the numerator. So I'm just going to distribute that. Then p squared plus p minus p squared plus 1. I'm distributing this negative right here. And down on the bottom, thank you, Cassie, for bringing up that 2. We have 2p squared minus 2 minus 2p squared plus. Now, if you notice, on top, we have a p squared and a minus p squared. They cancel each other out. On them, we have a 2p squared and a minus 2p squared. Again, they're going to cancel each other out. Okay? So, what we're with is going to be a p plus over a negative 1 in front, just because I don't like to start with a negative. So I'm 2p minus 2. Okay, it's done. There's one more thing I see that we can do. We can factor out a 2 on the bottom, and that'll be 2 times p minus 1. Okay, that's an answer. If it is, option D is p plus 1 over 2 times p minus 1. I know it's really messy. If anybody's having trouble following along, let me know, and I'll straighten it out for you. I think it was because this very large LCD, I had to kind of keep track of that along the way. And you see how I even dropped this 2 here. Thanks for bringing that up, Cassie. Track of what you're doing on these. That one. For 11, and we've got a request for number 2. Okay, 5 minutes, so I'm going to try to get this next one done. Go back and go to number 2. Oh, look here. 2 integers is 64. One integer is 20 less than twice the other. Okay, the important thing here is to name your variables. I'm going to use these words that they So I have one integer, the other integer. Okay, they talk about the one integer in terms of the other. So I'm going to make the other one my. I'm going to go back to the sentence here. One integer is 20 less than twice the other. Okay, twice the other, 2x. Twice than that is going to be minus 20. Okay, so I have defined my variables. The one integer is going to be the 2x minus 20. The other integer is going to be my x. Okay, so now it tells us the sum of these 2 integers is 64. Sum means I'm going to add them together. Okay, 2x minus 20 x equals 64. Okay, it's a pretty simple equation that you can solve. We're going to combine like terms. 2x plus x will get x minus 20 equals 64. Move that 20 over, so we're going to add it to both sides. Plus 3x equals 4. So when we divide both sides by 3, x equals 3 goes into 8 2 times with 2 left over. 3 goes into 24 8 times. So x is equal to 28. It says find the smaller integer. X is 28. That's this other number here. Okay, so I'm going to put 28. One number is going to be 2 times 28, 20. So 2 times 28, that is going to be 6 minus 20, that's 36. Okay, so the integer is 36, the other one's 28. We want to find the smaller, so it's going to be the 28. And that's the answer we choose. Okay, makes sense to everyone. Any questions on that one? I have one more request for number 29, so we're going to try to squeeze it in here. 29. Okay. So again, I think I'm going to open up a whiteboard for this one. Okay, let me get the whiteboard going. So, number 2. This equation. We have 3x squared minus x minus 0. Okay, we want to try to factor this equation. Anytime you have a quotient in front of your x term or your whatever your variable is, you want to think about doing the AC method. Again, I can't see my screen. You might have to stretch yours. So the AC method means we're going to multiply A times C. Our A is 3, and our C is the negative 20. Applying them together, we get negative 60. We're looking for two numbers that multiply to be negative 60, that add to be the middle term here, negative 11. Okay. Our factors of 60, we're going to have 60 and 1. We're going to get to negative 11 there. We'll have 2 and 30. That's not going to work. And 20, not going to work. And 15. I think I can get 11. So we need to add to be negative 11. So it looks like the 15 is going to have to be negative. The first is going to be positive. Okay, so now that we've figured out our factors, colors, we're going to go back and rewrite this equation. Squared. Instead of the negative 11x, we're going to use our factors. Negative 15x, 4x, minus 20 equals 0. Now that we have 4 terms, we are going to factor by grouping. So looking at these 2 terms, and then we'll separately look at these 2 terms. So we have 3x squared minus 15x. We want to come up with a GCF there. What's in common between those 2 terms? Well, we can pick a 3 and an x. Perfect. Okay, so we factor out a 3x. We're going to have x minus 5 left over. Okay, we're going to bring down this plus. That goes right there. Okay, so now looking at 4x and negative 20, what's in common? Out of 4. When we have 4, we're going to have an x minus 5 left. Okay. All right, this is when we know we've done things right. We've got x minus 5 in both cases. Okay, so that is what's in common now. So write it out. When we factor out an x minus 5, from this term, what do we have left? We have left. And then factored out from this term, we have 4 left. Okay, so now they're fully factored, and we can set each of these factors equal 0 and solve. 3, 4, 0. In this case, we're going to have x equals 5. And go over the negative 4. I have 3x negative 4 divided 3 equals negative 4, 3. Two solutions then. In this case, x equals 5, x equals negative 4/3. And the biggest thing that you had to do for this one is AC method. You can do this one by trial and error, but it takes a long time. And AC method works every time, so why not just go to what works every single time? So I think we're a little bit past our time limit. Thank you all for coming tonight. I hope you got something out of tonight's session. We did get to work a big variety of problems. There's a bunch more that you have questions on, and we will be back. Either I or Joe Houston will be back on Sunday night from 9 to 10 in the same meeting room. So I hope to see all of you there. If you can, come see us in the Academic Success Center on all the campuses. I'm personally at the Oviedo campus and would love to meet all of you. Good night.